First, the mole, how we define a mole of a substance. The definition of a mole, the mole is amount of substance in gram that has the same number of particle in 12 gram of carbon 12. This is a standard definition, but simply you can say mole is amount of substance which is expressed in gram. So if I say we have carbon which is 6 and 12. So what is the atomic mass of the carbon? This top number is the atomic mass or mass number, and here in the bottom it is atomic number. So when we have the same atomic mass or mass number in gram, we call that as a 1 mole of substance. So in case of carbon, because it is 12, so when we have 12 grams of carbon, it means we have 1 mole of carbon. And if we have 1 mole of carbon, 1 mole of any substance will have 6.02 into 10 to the power 23 particles. Because this time we have atom, so the particle we can specify as atom. So 1 mole of any substance contains 6 exponent 23 particles or atoms, and mole is the amount of substance which is expressed in gram. So atomic mass or molecular mass which is expressed in gram is simply called or known as the mole. Same way, like example, if I say H2O. So in H2O, hydrogen is 1 and multiply by 2 plus oxygen is 16 multiply by 1, so total will be 18. So if we have same amount, same molecular mass in grams, so if we have 18 grams of H2O, how many moles will be there? It will have 1 mole of H2O or water, and 1 mole of water, because these are group of atoms or molecule, so it will have 6.02 into 10 to the power 23 molecules. Is it clear? The concept of the moles? The mole is simply amount of substance which is expressed in gram. Another example, if we have 24, as we know magnesium is 12 and 24. So if we have 24 grams of magnesium, it means we will have 1 mole of magnesium, and 1 mole of a magnesium will have 6.02 into 10 to the power 23, because magnesium is the atom, so this will be atoms. If we have half of it, like half of 24, which is 12, so if we have 12 grams of magnesium, it means we will have 0.5 moles of magnesium, and because it's an atom, so this will be half mole, so 3.01 into 10 to the power 23 atoms will be there in this half moles. So mole is simply amount of substance which is expressed in gram. Then you should be able to define a term relative atomic mass. How we define a term relative atomic mass? So when we have a substance, as we know that carbon, it is 12 and 6. So we have a carbon 12 and we divide this carbon 12 into 12 equal pieces. So we divide this carbon into 12 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So if we have carbon 12 and we divide this into 12 equal pieces, so mass of each will be 1 unit, like each will be 1. So theoretically, when we compare this, so we have like a balance, and we have an unknown element X. We don't know its mass. So an unknown element X is there, and to balance this X, we took 3 units of carbon 12, 3 parts of carbon 12. So if we took 3 parts of carbon 12 to balance X, so what it shows, the number of the units which we use to balance, because the mass of each unit is 1. So number of units of carbon 12 we use to balance this X, that will be the mass of this X. So if it's an element, it will be, or if it's an atom, it will be atomic mass. If it was a molecule, then it will be a molecular mass. So what is X? The mass of X. Mass of X will be 3. So we can say relative atomic mass. If it was an atom, then we say relative atomic mass is equals to 3 units. Is it clear? The concept of relative atomic mass? It's a mass of element which is compared with the 12th part of carbon 12. And if there is another element, element Y is there, and its mass is unknown, and we took 5 units of carbon 12 to balance this. So what is the mass of this element Y? What is a relative atomic mass? We can also represent by AR, capital A and small r. If it's an atom, then atomic mass, if the element is in a molecular state, or if it's a compound, then it will be a molecular mass. So in this case, what is the relative atomic mass? So relative atomic mass will be equal to 5. So if element is existing as an atom, then it will be atomic. But for example, if it was a molecule, like example, it was Y2. Group of atoms are known as molecule. So if it was Y2, we will not write atomic mass. In that case, what we'll say? We'll say it is relative molecular mass. And then we represent by capital M and small r. So in that case, relative molecular mass will be equal to 5. So if it is a molecule, then molecular mass. If element exists as an atom, then atomic mass. Or if it was a compound, then also it is a molecular mass. Then what is molar mass? Molar mass is a mass of 1 mole of substance. So the mass of 1 mole of a substance, that's called a molar mass. Example, hydrogen, which is H2. So hydrogen is H2. What is the molar mass of hydrogen? Because mass of one hydrogen, relative atomic mass of hydrogen is 1, and multiply by how many hydrogen are there? 2. So 1 multiplied by 2, 2 multiplied by 1, or 1 multiplied by 2. So this will be 2, and the unit will be gram per mole. Like if we have 1 mole of hydrogen, it will have 2 grams for each mole. Same thing, 1 mole of calcium carbonate, CaCO3. So what is the mass of 1 mole of calcium carbonate? Calcium is 40 plus carbon is 12 plus oxygen 16 multiplied by 3. So 40 plus 12 52, and for 16 multiplied by 3 is 48. So total will be 100. So the final answer will be 100 gram per mole. So the mass of 1 mole of a substance, which is expressed in gram, that is called a molar mass, and the unit of molar mass is gram per mole. Same way, 1 mole of oxygen. Oxygen atomic mass is 16 multiplied by 2. So 16 multiplied by 2, that is equals to 32 gram per mole. 1 mole of H2SO4. Hydrogen is 1 multiplied by 2 plus sulfur is 32 plus oxygen 16 multiplied by 4. So this total will be equal to 98 gram per mole. So molar mass is simply the mass of 1 mole of a substance which is expressed in grams. Is it clear? The molar mass. So these are the definitions which are important. The first one, which is about the mole. So the mole is the amount of substance in gram that has the same number of particles as the atoms in 12 gram of carbon 12, or 1 mole of carbon 12. How many atoms are there? Same number of particles, or Avogadro. You can also say mole is amount of substance which contain Avogadro's number of particles. The definition of relative atomic mass, it's an average mass. It's important you use the term average. So average mass of one atom compared with the 1/12 of carbon 12. So this is a standard definition. And the molar mass is a mass in gram of 1 mole of a substance, and the unit is gram per mole. Is it clear, the three definitions? The concept of mole, the relative atomic mass, and the molar mass. Then there are some formulas which we use to calculate the moles depending on the question. So for most calculation for AS, we'll use these following equation, three equations. Number one, for pure solid and gases, the formula which you use, amount or moles, instead of amount you can say moles, equal mass in gram divided by molar mass. The second formula, volume of a gas in dm cube is equals to amount. Here the term amount means moles, multiplied by 24. And this formula is only valid when there is a 25 degree centigrade or 298 Kelvin. So when it is 25 degree centigrade or 298 Kelvin and the pressure is 1 atm, then only we use this formula to calculate for gases. And if we are calculating solution, then concentration is equals to amount divided by volume, or moles divided by volume. The unit conversion, volume should be in dm cube. So if you want to convert cm cube into dm cube, we should divide by 1000. If you want to convert cm cube into meter cube, then we should divide it by 1 million. And dm cube to meter cube, again we should divide by 1000. So simple questions are there, some simple calculation using the above equation. So the first example, what is the amount in mole for 35 grams of copper sulfate? So 35 grams of copper sulfate is there, mass of solid is given, so we use the first formula. So the first formula, moles equal mass in gram divided by molar mass. So mass in gram is 35. What about the molar mass? So we have to check the periodic table. We have copper sulfate, so which is CuSO4. You can see the mass of copper 64, mass of sulfur 32, and mass of oxygen is 16. So when you are working out the molar mass of copper sulfate, so copper is 64 plus sulfur is 32 plus oxygen is 16 multiplied by 4. So this will give you the total mass of copper sulfate, which is in the table, the periodic table exact is 63.5. So you'll substitute 63.5. So the total mass and the moles, when you divide them, you'll get as 0.219 moles for copper sulfate. For example 2, they are asking what is the concentration of a solution made by dissolving 5 grams of sodium carbonate in 250 cm cube of water. So to get the concentration, we need the last formula, but directly you cannot use the last formula. Why you cannot use the last formula? Because here amount of moles to get the concentration, and you need a volume. You have the volume, but that volume is in cm cube, so you have to convert it to dm cube. But you don't know the moles, you don't know the amount, you have the mass. So first you have to use the first formula, that moles equal mass in gram divided by molar mass. So molar mass of sodium carbonate, sodium is 23 and multiply by 2 because 2 sodium are there, plus carbon is 12 plus oxygen 16 multiplied by 3. So this will give you the amount of the moles, which are 0.0472 moles. So these are the moles of sodium carbonate. You need concentration, which is mole divided by volume. So 0.0472 are there. And what about the volume? To convert this cm cube into dm cube, you have to divide by 1000. So when you divide by 1000, it will come out as 0.25 dm cube. So the concentration, moles divided by volume, so you'll get as 0.189 mole per dm cube as a concentration of this. Is it clear? The second example, how we calculate the concentration. And about the third one, what is the volume in dm cube at a room temperature? So room temperature is considered as 25, because in the question if they specify it's a room temperature, so you consider that as 25. Otherwise, if it is temperature is not 25, then you cannot use this formula. Then we use another formula that we'll discuss later in the class. So what is the volume in dm cube at room temperature and pressure for 50 grams of carbon dioxide? So first, because to use this formula, we should know the amount, the mole, and then we'll multiply by 24. So from mass in gram divided by molar mass, carbon dioxide molar mass is 44. So we divide, we'll get 1.136. And after getting the moles or amount, multiply by 24. So we'll get the volume in decimeter cube. And whenever you write the answer, you should always write your answer in 3 significant figure. So it will come out as 27.3 decimeter cube. So these are the 3 examples related to the formulas. Number 1, moles equal mass in gram divided by molar mass, usually used for pure solid and gases. The second one, moles equal volume of a gas equal moles or amount multiplied by 24, and the third one for solution concentration is equals to moles or amount divided by volume, but the volume should be in decimeter cube. Then how to find the number of the particles or concept of Avogadro's constant? So we know the mole is the amount of substance that has the same number of particles as there in carbon 12, 12 gram of carbon 12. And 12 gram of carbon 12, how many particles are there? It contains 6.02 into 10 to the power 23 particles. So if we have 6.02 into 10 to the power 23 particles, we call that as 1 mole of a substance, as this number is known as Avogadro's number. So if we have 1 mole of copper, so 1 mole of copper atom, how many particles will be there? It will have 6.02 into 10 to the power 23 atoms, because it's an atom. But if we have 1 mole of carbon dioxide is a molecule, so it will contain 6.02 into 10 to the power 23 molecules. And 1 mole of sodium ion will contain, if substance is an ion, then it contains the same particles or number in ion. So 1 mole of a sodium ion contains 6.02 into 10 to the power 23 ions. And how we get the number of the particles? So number of particle is amount of substance or mole multiplied by Avogadro's constant. So in the first example, how many tin atoms are there in 6 gram of sample? So how we work out? First we'll work out the moles or amount. Mass in gram is 6 divided by relative atomic mass, because tin is an atom. Metal is their atomic relative atomic mass we use. So we'll get the number of the moles, and number of moles multiplied by Avogadro's number. So it will have 3.02, 3.04 into 10 to the power 22, and this time it will be atoms. And same question, how many chloride ions are there? How many chloride ions are there in 25 gram of solution of magnesium chloride of concentration 0.4? So how we can work out this? We need only chloride ions. So if we need only chloride ion, first what we do? We'll get the moles of magnesium chloride, because they're asking how many moles are there, how many chloride ions are there in 0. In a concentration of MgCl2 is 0.4 mole per dm cube, and volume of magnesium chloride 25 cm cube, so divided by 1000, it will come out as 0.025. So first what we will do, to get the total number of chloride ion, first we should know moles of magnesium chloride. So moles of magnesium chloride, moles is concentration into volume. So concentration is given 0.4, volume is there 0.025. So when we multiply them, 0.01 moles will get. So these are the moles of magnesium chloride, but they're not asking for magnesium chloride moles, they're asking for total number of ions of chloride. So to get the total number of chloride ion, we should know how many chloride ions are there. So we have magnesium chloride. When it dissociate, it will dissociate into magnesium ion and 2 chloride ions. So what is the ratio of magnesium chloride to chloride ion? It is 1:2. Like 1 mole of magnesium chloride gives 2 chloride ions. So if we have 0.01 moles of magnesium chloride, then how many chloride ions will be there? X. We cross multiply. This will give us the moles of chloride ion, 0.02 moles of chloride ion. And now to get the number of the ions, number of ions is equals to amount or mole multiplied by Avogadro's number, which is 6.02 into 10 to the power 23. So 0.02 are the moles and 6.02 into 10 to the power 23. So we'll get the total number, which is 1.2 into 10 to the power 22. Chloride ions will be there. in this magnesium chloride. Is it clear, this example? So first what we did, we work out, because we were having the amount of magnesium chloride, so using the volume and concentration of magnesium chloride, we got the moles of magnesium chloride. And then we use a ratio to know the moles of chloride ion in magnesium chloride, as the ratio is 1:2. And after getting the moles of the chloride ion, multiply by Avogadro's number to get the total number of chloride ion in the solution. Is it clear, this example, to everyone? Yes, Saleh Abdullah. So same way we can use this to work out the molecules, to work out the atoms. So if I say I have um, 22 grams of carbon dioxide, find total number of atoms. So we have 22 grams of carbon dioxide and we want to work out the total number of atoms. Carbon dioxide is a molecule. So first we'll find the moles of carbon dioxide. So moles of carbon dioxide, mass in gram divided by molar mass. So mass in gram is 22, molar mass of carbon is 12, oxygen 16 multiplied by 2, so total will be 44. So we'll get 0.5 moles of carbon dioxide. But how many atoms are there? That's the question. So one molecule, so what is the molecule to atom ratio when we have one molecule of carbon dioxide? How many atoms are there? It contains carbon, it contains oxygen and oxygen. So the one molecule contains basically 3 atoms. So in one molecule there are 3 atoms. So if we have 0.5 moles of carbon dioxide, how many moles of atoms will be there? X. So it will be 1.5 moles of atom. And to get the total number of atom, what we'll do? We'll multiply by Avogadro's number 6 into 10 to the power 23. That will give us the total number of atoms. If they ask for molecule directly, because carbon dioxide is a molecule, we'll multiply this number by 6.02 into 10 to the power 23. But because we are asking about the number of atoms, so we have to convert the number of molecules to number of atoms, or moles of molecule to moles of atoms, and then multiply by Avogadro's number. Is it clear, this example? So it depends on the question. If they're asking for ions, like you have say aluminum chloride, AlCl3, and the question is find the ions, total ions. So the ratio of aluminum, because aluminum chloride will dissociate into aluminum ion and 3 chloride ions. So the ratio of the molecule is to ion is 1:4. So you can work out the ratio and find the number of ions. So today we discussed the main concept of the moles by using a formula and working out different example, finding the number of particles. In the next session, we'll discuss the general gas equation. Any question related to the class today? So I'll end the session and share this recording with you. You can copy the lecture notes by using the video recording.